is on African genomic research. We have 3 chairs and we have 3 speakers. One of our speakers was unable to make it, that is Christian Happy, but we're delighted to have really 3 very exciting talks ahead of us. So it's my great pleasure to welcome as the first speaker Professor Charles Rotimi. So Charles is no stranger to any of us, and many of you will know that he is the founding president of the African Society of Human Genetics. Charles, you have been a force in terms of genetics on the continent, and I can't see you right now, maybe you can wave. But I would like to invite you to come and give your address, which is talking about African genetic diversity and the dawn of precision medicine. This is really a very important topic, and Charles has been instrumental in formulating our thoughts behind genomic science across the continent and developing a pan-African flavor for genomics. So Charles, I'd like to invite you to the podium. If anybody can locate our first speaker. Charles, I've just introduced you. Are you ready for your presentation? Fantastic, very perfect timing, just coming through the door. So thank you so much. You need to get some water. Perfect. And I've done the introduction, so I really would like to invite you to come and talk. We're really looking forward to this fantastic talk. Thank you.
Okay, thank you. Good morning, everybody. It's indeed a great pleasure to share with you some of my thinking about the society and also genetics in Africa, and put it in the context of what we call precision medicine today. So, I say you've heard this all through the morning. This society is where we come together to dream, and it has indeed been a place where we dream big, and we engage the whole continent and we engage the whole globe. Part of that dream occurred here 10 years ago in terms of how do we make sure that genomics is indeed a successful tool that is used to improve the health of Africans, with Africans directly contributing to that effort. So in 2007, we had this wonderful meeting here in Egypt, and you see the picture there in the middle, and you see Francis Collins right in the middle of that picture, who is now the director of NIH, was here to dream with us in terms of how to engage Africa in genomics. And that led directly to what we are talking today, a high praise for H3 Africa. But one of the things I want to point out, H3 Africa is a tremendous success, today. But it wasn't always so when we started thinking about it, because we didn't know where the money was going to come from and all that. So what I would say is that it's good to dream, and hope that that dream becomes a reality. And again, H3 Africa is a wonderful example of that. So I want to use this opportunity to congratulate the society for bringing Africa to the forefront in terms of human genetics. And I also want to use the opportunity to thank our Egyptian colleagues that helped us to organize this meeting in 2007. And I just met old friends, today. We had Ahmed and all the other colleagues that actually helped us to organize that meeting. Again, thank you very much. So, again, I say this is where we dream, and I want to challenge the society today, again, to dream big. What is the next best thing for Africa in terms of genomics? And I'm proposing that we tackle what we call the 5 million Pan-Africa cohort, where we develop a wonderful cohort that is going to give us information about disease prevalence, about disease causality and risk factors, and will help us to put us in the context of human genetics And from there to graduate to the ability to use that information to drive what we call individualized medicine, or what some may refer to as precision medicine. So this is my challenge to society, for us to think about this and see how we can dream about this and make this a success in the continent, given what we have done with H3 Africa and other initiatives. So, I know some of you will say, oh, Charles, how are you going to do this? How are we going to do this? Where's the money going to come from? I'll say, but if you don't dream, it will never happen. So, let's go for it. Now, you see the title of my talk, it says African diversity in the context of precision medicine. But to me, it's always very important. What do we mean when we say Africa or Africans? What is the meaning of that? One way to look at it is to say everybody on this planet is African. Because we all started from here, our ancestors started somewhere from Africa before we migrated to different parts of the world. So I always sort of use this expression to say that we are all Africans beneath our skin. And if we appreciate that, we will actually appreciate the need and how precious it is for us to engage Africa in terms of genomics, because we will be describing human genetic variation if we do that and do that correctly. So, one of the other things I want to make very clear, again, when we talk about Ancestry Africa, is who are we and where are we really from and who are we related to? One of the important things that is not adequately respected or appreciated across the globe is that all human beings, we are a mosaic of different things. It just depends on where our ancestors have been. And if we read our genome correctly, we will for the very first time begin to appreciate the diversity of our ancestry. For example, this is a study that we did from my lab at the NIH, where we studied almost 6,000 individuals from 30 language groups. And we were able to identify up to 21 ancestries. What is really interesting here, of these 21 ancestries, 11 are from Africa. So you can see that all of these ancestry, 11 of them you can capture in recent populations of African ancestry. But the most interesting thing here is that if you look at that cartoon that is showing different colors there, each line represents a human being. And as you can see, there's no human being on there that has a solid color, which will mean that they have only one unique ancestry. All of us are combinations and that, and we need to emphasize that and appreciate that, especially if we are talking in the context of precision medicine. Okay? So, that particular point I want to drive home, that sometimes we use skin color or we use just looking at individuals to make decisions in medicine. That is not only wrong, it can actually put people in danger. By not appreciating that you cannot look at me and determine the kind of genetics that I carry. You have to understand my history. So that is very important. I want to use an example to push that point home. The title here of this paper was called the Medicalization of Race, the Scientific Legitimization of a Flawed Social Construct. We use this word race, as if there are multiple human races. So this is a serious negative consequence. Our 8-year-old boy, phenotypically European, presented with acute abdominal pain and anemia. Although his body temperature was 37.9 centigrade, surgery was considered. A technician found red corpuscles with hemolytic characteristics on his smear. Surgery was cancelled after the results of the subsequent sickle preparation was found to be positive, and the child was tested for previously undiagnosed sickle cell anemia. The take-home message here is his parents were from Grenada and were of Indian, North European, and Mediterranean ancestry. You couldn't tell all of that by looking at this child. And physicians look at this child, they never thought about sickle cell because they were using skin color and thinking sickle cell is African or something to do with black. No, it has to do with your ancestors being need to survive areas that have been endemic in terms of malaria. So again, it's really important for us to appreciate that. And the other thing I wanted to ask is, who is black? How do we understand that? We can use skin color. For example, you look at this wonderful tennis player and golf player here, Tiger Woods, and I'm not sure if I have it pointed here. Anyway, but the important thing here is that if you look at somebody like Osaka, this lady, she has an Asian father and a Japanese mother. Looking at her, you can tell. So you have to appreciate that complexity. So it's important for us to appreciate that when we're talking in terms of pharmacogenomics or precision medicine. So for me, the way I look at and define African, it has to be time frame. So I'll say recent Africa, which is different from the prehistoric migration out of Africa to different parts of the world. So recent African ancestry, and also individuals of African descent who migrated to different parts of the world, especially during the slave trade, to the Americas and to Europe and to different parts of the world. If you look at those individuals, you'll see that the individual African admixture proportion range from 0 to almost 97%. So it's again very, very important observation for us to make. The other point I want to make is from this paper that we published a few years ago with the African Genome Variation Project. Again, by typing different African ethnic groups, we were able to show also that there is significant Euro-Asian mixture ranging from about 0 to 50% in African ancestry, and hunter-gatherers admixture ranging from about 0 to about 23%, and not just only in South and Eastern Africa, that we also saw evidence in West Africa. Okay. So for me, when we say people of African ancestry, it's all of us, really. And we are from different backgrounds, different diversity, and we need to appreciate this if we are going to indeed do the precision medicine initiative very, very well on the African continent. The example I gave you is from Brazil. And Brazil has the largest African ancestry population outside of Africa. And the recent census of Brazil showed that 50% of Brazilians, which is about 200 million people, self-identify as persons of African ancestry or of mixed ancestry. So again, that is very, very, very important as we understand, and we use the word African in a very global sense. Okay? So, what is the genomic data telling us about what is telling us about the African story, and what are we learning? Some years ago, I was the principal investigator that engaged the African continent for the half map, as you will see in that picture. So the Yoruba community, the Luya and the Maasai community in Kenya. Again, this was an effort to make sure that we represent the African genome in a global initiative. But we were very, very conscious that by studying these three populations, it doesn't even come close to understanding the diversity across Africa. Those resources and more now have become part of the 1,000 genome that we are now again using in terms of the sequencing revolution. But what are the characteristics that these have shown us in terms of the African genome and in terms of the diversity of Africa? As you will see at the bottom, I don't know, maybe those chairs may be in the way, I'm not sure you can see it in terms of the label. If you look at the private allele or variation present in the human genome, the highest proportion of that private variation is seen in African people. That is really, and that is the yellow colorations. We can indeed come very close to represent all human variation, but again, there are some variation that has not had time to spread from different parts of the world. That is why it's important again for us to study all human populations. So this is the first characteristics of the African genome. It captures most of the diversity we see across the globe. And by studying Africans, we can indeed make very good statements about diversity across different parts of the world. So, another characteristics of the African genome is the number of variant sites per genome. As you will see on the right-hand side of this first cartoon here, you'll see that the African populations in the 1,000 genome has more variant sites per genome. And for example, for SNPs, about 4.3 million variant size in African ancestry populations compared to other world populations. And the number of non-synonymous variants also much higher in Africans, and loss of function variants is also more common across African populations. So again, the other cartoon is average number of detected variants by genome. As you will see, close to the left-hand side of that graph, you see most of the African populations have more of the detected variants by genome, again, telling us about the characteristics and the architecture of the African genome. So why is all of this important? It's really important in the sense that if we start to characterize haplotypes and characterize our ability to use genomes to answer different questions. So, for example, recent African populations has the highest number of haplotype structures, and those haplotype structures in terms of huge diversity, as you will see again on the left-hand side of this cartoon. And there are also shorter linkage disequilibrium structures across African genome, such that we can use the African genome to find informations or loci that we see in European or Asian populations, and that's what the other cartoon is showing. What you will see is that in African ancestry population, which is the orange color, you will see that the region that you picked up in genome-wise association is much shorter than the region you pick up in other populations. Therefore, it's going to help you to better localize perhaps the causal variant for that phenotype that you are studying. Again, another characteristic of the African genome. So this is an example to illustrate that point. The TCR7L2 is one of the most replicated variants for type 2 diabetes. By looking at the African genome, in this case, specifically West Africans, we're able to localize what we consider the probable causal variant for this particular gene. And as you will see, you have a better definition of that variant site when you look at the African genome. And on the other side, you will see the structure, again, the fine-grained structure of haplotypes in the African ancestry population compared to European populations, which again helps you in terms of fine mapping. Okay? So in terms of pharmacogenomics, one of the points we want to make here, this is a data set that we put together in my lab. This data is publicly available. If you want to use it, just let us know. But the point I want to make with this presentation is that as you look at the warfarin dosing, the FDA, that's the Food and Drug Administration in the United States, they use haplotype frequency to estimate warfarin dosing. Okay? But when we did this study, we found a haplotype that is currently not used in this dosing algorithm, but it's actually quite frequent across different African populations, from about 40 to about 7% among the Maasai. So again, this is very, very important, diversity across different African populations. This is another example of the diversity and why we can now use one African population for another in terms of this type of pharmacogenomic studies. There's been a very serious warning about the use of codeine in children. It turned out that the frequency of this particular deleterious variant that put people at increased risk when you give them codeine is very, very high among Ethiopians, up to about 30%. And if you look at other African ancestry populations or global populations, it's actually much, much lower. This was very important information in terms of Ethiopia, and because there was no structure to actually genotype individuals before you give them codeine, there's now a ban on use of codeine in Ethiopia. So hopefully with time, instead of banning codeine completely, we can indeed type individuals and see who will benefit or not benefit from codeine use. Okay? So, throughout my talk, I'm going to continue to highlight a very important point. The diversity in Africa is well recognized, but we forget when we use the word African all the time in our study design, that is indeed a very real concept in terms of diversity. So this is, I call this the danger of group labeling in terms of definition of human genetic variation. As you guys know, or people who study HIV, there's an adverse reaction due to a particular HLA variant that it causes it has a negative predictive value of almost 100%. But the frequency of this particular variant varies quite highly across global populations, especially in Africa. The Maasai has one of the highest rates in the world, about almost 14%, and it's almost not present in Yoruba populations. In African Americans, about 1%, and in European population range from about 3 to about 6%. But the point I want to make here is that if you use the label black or African, you distort this huge variation for this particular allele, and you may reach a wrong public health decision as to who to screen, because you are using the words like African or black, to define this very, very genetic variation that we see. So again, trying to drive that point home. It's also very important for us to make sure that we recognize that by increasing the diversity of what we study at the genome level, we can indeed discover new things. And I'll show you several examples of this. The PCSK9 and LDL cholesterol is a very, very good example. This mutation was picked up in African Americans because it's about 2%. It's rare in Europeans, and it's associated with 40% reduction in LDL level. It's now a drug target in terms of the treatment of LDL or high cholesterol. But we couldn't find this really, or not efficiently anyway, if we have not studied a diverse population, in this specific example, African Americans. I think Andrews talked about this example of not having adequate reference and reaching the wrong conclusions by calling variants deleterious when indeed they are not. So again, just another way to emphasize that point. And this is another good example in terms of treatment for TB. There is an adverse reaction that comes with some of these drugs in terms of liver toxicity, which leads to treatment failure and interruption and drug resistance, morbidity and mortality. The allele that, or the SNP that increases this risk, specifically the ROS1495741, is highly variable across different African populations. Just about everybody in Ethiopia carried this variant, for example, and if you look at other African populations, it's much lower in terms of frequency. Again, driving the point home that we need to make sure when we use the concept of Africa that we are not making assumptions about human genetic variation across the continent. This is a very relevant example in terms of health disparity. Okay? So we are, hepatitis C is a very deadly disease, affects about 170 million people worldwide, leading cause of cirrhosis. And there's about 48 weeks of treatment with the combination drugs. But for a very long time, physicians have recognized the fact that individuals of African ancestry benefit less with this combination therapy, and nobody really understands the reason why. But there was a publication in 2009 by David Goldstein group that shows that there is a particular SNP on interleukin 28B that affects treatment level. As you will see in that cartoon, if you carry this the C allele, you have a much better response to this treatment. And it doesn't matter whether you're white, black, or Asian, you just carry that particular variant. But what was actually striking about the result is that if you look at the frequency of these variants in different ancestral populations For example, in African ancestry populations, about 10 populations, you see the frequency about 36%. In Europeans, about 68%, and in Asians, just about everybody, about 95% carry this variant. So these differences in allele actually explain almost 50% of the differences in response to this particular drug. So you can see how this again can inform, lack of response by ancestry. APOL1 is our best example today in terms of complex diseases, why it's important to study ancestry, and also a cautionary tale about the label we put around the variants that we pick up. For example, in African Americans, 13% of the US population, but they have 32% of kidney failure. Okay? So 1%, 1 in 5 people carry the APOL variant. And it explains a tremendous disparity that we see in terms of kidney failure when you compare African American to European populations. And the variance of this, the frequency of this variant is also quite high in populations in West and East Africa that have been endemic in terms of trypanosomiasis, the African sleeping sickness. So this is again very, very important for us to appreciate this. But the point here is that this variant is not a characteristic of being African. It is a characteristic of being your ancestors coming from He just gave me five more minutes. Okay, that's cool. So this is again, like I said, a characteristic of your ancestors having been in surviving areas of trypanosomiasis, African sleeping sickness. But the important characteristic here is that this is now the cost of that protection that you see from this variant is kidney failure for people who grow old enough to get kidney disease. And it's indeed very, very important in terms of what we are seeing for survival for people who have kidney transplants. It turns out that if you transplant kidney from somebody who carried 2 copies of this variant, the kidney has a higher probability of failing compared to kidney from individuals who don't have 2 copies of this particular variant. Again, having direct clinical implications. So the cautionary tale here also is that when this came out, people were describing this as if it was a characteristic of being African. It is not a characteristic of being African, again, like I said. And individuals who may not look African actually carry these variants, depending on if they have admixture from people who come from that part of the world. An example that I'm giving here is the people who call Hispanic Americans, which are basically from the Spanish-speaking part of the world. And you will see that they actually, for some of them, they carry this APOL1 variant, which you cannot guess by looking at them. And it turns out that under that genetic background, the risk is actually much higher than what you see in African, odd ratio of 15 compared to about 10. So again, part of the cautionary tale here. This is an example from my lab again, where we found a variant for metabolic syndrome that is African specific. So we discovered 2 variants that have an odd ratio of almost 7 for this CA10 gene. And we also found one that was highly protective in terms of African ancestry populations, although we also picked up variants that are also cosmopolitan, that is, they are found in different world populations. But the point here again is that by studying different African populations, and different ancestral background, we can discover new things that you would otherwise not see if you concentrate on only one ancestral populations across the world. This is another example in terms of obesity, where we find a variant that is 1% in West Africans, in African Americans, and it increases the risk of obesity. And sigma 4D, again, and 2 lead authors here, I think they're in this audience, Gwanji and Ayo Dumate. I think you'll be hearing from Ayo somewhere during this presentation. And Gwanji has a poster. Sure. The other point I want to make here is gene-environment interaction. This is a study, again, coming out of my lab with, with collaborations from different parts of the United States and in the world. This is a cohort of almost 400,000 individuals, where we are looking at gene-environment interactions under the charge consortium. We are trying to see how does smoking influence what we see in terms of lipids. And it turned out that we picked up a lot of variants for lipids without taking into consideration smoking. But if you take into consideration the interaction with smoking, you learn new things. So if you look at this particular SNP, just by itself, it is not significant. If you look at it by adjusting for smoking status, it's still not significant. If you look at non-smokers only, it's still not significant. But look at what happened if you put interaction term in it. So you will see that it becomes highly, highly significant. And if you look at it by interaction and main effect, you will see the significance even go up. So by taking into consideration gene-environment interactions, we actually discovering new variants and understanding biology better. So right now we are trying to explain why we see this in terms of gene-environment interaction for smoking and lipids in African Americans specifically. So again, smoking is very, very important in this investigation. So coming down to the sort of the end of my talk, again, my title of my talk is African Diversity in the Context of Precision Medicine. The point I want to make here is that to ensure that tomorrow's medicine and technology works for all human beings, we have to engage all human populations. I hope I have convinced you that genetic diversity is indeed important. Sorry. Give you more time. Okay. So I need to wrap up. I think that's the point here. Okay. All right. So it's not advanced anymore. Hello, advanced. Okay. So I introduced a challenge to the group earlier by saying we need to think about the 5 million Pan-African cohort. Now here in this slide, I'm giving it a name. I'm calling it all of Africa. As we move forward, I know it's a dream, but we need to dream big. And I want to just say to you again that the American Society of Human Genetics is trying to engage Africa more directly. So I'm advertising this, and I told the program people to give me something to present to you that there is consideration. Please submit abstract to the American Society of Human Genetics, and you can get sponsorship to go to that meeting. Again, very, very important. And again, I want to go back to the fact that we started here in Egypt. That was my last. We started here in Egypt, and that one of the things I wanted to just say is to thank individuals who organized that meeting in 2007, and to show some pictures, especially that one, the way I'm dancing, doing with the belly dancer. And I hope we will do that again during this trip. It was actually quite interesting. And I want to say thank you to my group, and I'm glad to take any questions that you may have.
Thank you very much, Charles, for a fabulous talk and for giving us this challenge of what we need to do going forward. So I think you've had a few challenges already this morning, and I think I would invite you to ask some questions. We're just going to give 2 or 3 minutes for questions before we move on to the next speaker. So please do come forward if you have a question.
Thank you very much for a very good talk. My question is, at what point do we stop the word diversity? We know that the whole world is very diverse. And you also mentioned that Africa is diverse. Now, for example, if you pick one of the regions you mentioned, the Yoruba region, very diverse region also. You see that the Africa is diverse, and if you look at the Yoruba also, if you look at the tribe, within the Yorubas, they are also very diverse. So at what point do we cut down the word diversity? Because if you start going down, going deep into the tribe, you also see that people are very diverse. So at what point do we cut off that word diversity?
Until we study every single human being. The point here is that it's not to stop diversity, it's to understand that the diversity, the ultimate diversity is the individual. And you cannot really put a boundary on it in that context. But does that mean that we cannot make progress by designing a study that doesn't include everybody? No. So as we define studies and we understand human diversity more and more, we are making the reference database better and better and better. And the example that I usually use to answer your question directly is, if you are interested in the pharmacogenomics of chloroquine, okay, myself and my mother, we will belong to two different groups. Why do I say that? When I grew up in Nigeria, in those days, this will tell you how old I am, the treatment we used to get was chloroquine. And after chloroquine treatment, my malaria goes away, the same thing with my mother, but I have major adverse reaction to chloroquine, which my mother doesn't have. So if you're interested in the pharmacogenomics of that, you have to put us in different, you see what I mean? Diversity is actually comes down to the level of the individual. But we can design studies to enable us to continue to appreciate that. I dance around a lot, so we can continue to develop studies that will enable us to capture more of this diversity. Okay? Yeah.
Perfect. Thank you very much. Any other questions for Charles? This is your chance. I think we're still warming up, Charles, but this was a fabulous talk, so thank you so much.
Okay.
I think I'm going to hand over to our co-chair.